Here's problem number 47. And indeed what we're going to try to start with this problem is we're going to look at the graph of this thing before we attack it. Right? Now what do we mean by the graph of this thing? It's in the form r squared is equal to something. And our calculator does not handle that idea very well. In fact, we're expecting that the function should be in the form r equals. So let's do r equals the square root of, and what was the problem again?
4 cosine
4 cosine 2 theta. Okay. Now, while this is graphing, and I'm going to do a zoom 0. I'm going to do a zoom fit. While it's graphing, I want you to realize and say that the thing that we're up against is that the area of some polar curve is easy to do. It's 1/2 r squared d theta, integral over some range of thetas. The hard part is not this part. It's not the hard part is not in the integram. It's a memorize. It's 1/2 r squared. Done. The hard part is, what are the limits of integration? And we've got this thing that looks a lot like a figure 8. Now, I don't know if you noticed which parts of the curve got drawn first, second, third, fourth. Okay? Now, the way my grapher is set up right now, theta is ranging from negative pi to pi. Okay? And what I'd like to do is I would like to try to focus on this question. Can we find the values of theta that produce one loop of this lemonscape?
What is a lemonscape? That is a lemonscape.
The graph of that thing is called a lemonscape.
Why is it not finished?
Well, it's not finished simply because my theta step was too big.
Why does mine not look like that?
0 to pi over 2.
Okay, let's go ahead and let's do 0 to pi over 2. And let's see what ends up happening, all right? And since this is a smaller range, I might even be tempted to make the step 0.001 so that we can see the entire curve. I don't need to do a zoom fit again. My window is already, in terms of x's and y's, the right dimensions. I'm just going to go and I'm going to hit graph. Okay? So there it's graphing. So probably when it started at 0, it started right at, I'm going to guess that that's 2, 0 in the xy coordinates. Okay, and it's going up here. Perhaps I should not have used such a small theta step.
But then we can see exactly where.
Oh, we know exactly.
I mean, this is
It's making the cubes and everything.
All right? Now it's done. Or is it?
No.
Or is it?
The worm is still going here. So what is that? It's either retracing over the other part, or are there values of theta for which r squared 4 equals 4 cosine theta doesn't exist?
Yes.
Anytime that cosine produces a negative value, you can't have an r squared value, at least in the real numbers, that's going to work. So I would say that it's not that it's retracing. What I think it's doing,
It's going through the negative.
it's going through the negative areas. Now, Sarah, you had proposed try 0 to pi over 2. I don't think we need to go as far as 0 to pi over 2. And now that we've got this insight about the negative things, let's think about values of theta that will produce negative values out of cosine. Typically, we talk about cosine being positive from like negative pi over 2 to pi over 2. But this isn't cosine, this is 2 cosine. So what range of values?
Negative pi over 4 to pi over 4.
Negative pi over 4 to pi over 4. I think is probably what we're going to go for. Let's just see if that makes sense. I asked the question, what value of 2 theta gives me pi over 2? That place where cosine is 0. Oh, it happens when theta is indeed pi over 4. What's another value that of 2 pi where cosine is 0 at negative pi over 2? And of course, this yields that theta is negative pi over 4. So indeed, I think if we went from negative pi over 4 to pi over 4, that we're going to get one loop of this lemonscape. Let's try that. Window, negative pi over 4, pi over 4, and so that it's not as bad, I'm going to go back to my old value of 0.01. Right?
You do 0.005.
I could, but I'm going to be okay with the fact that it doesn't make it all the way back to the origin.
Because we didn't get the
Because we know, well, we've seen it go to the origin.
Why do you take it all the way back to the origin?
It has to do with some rounding. So, all right, I say that indeed one loop of this is going to go from from negative pi over 4 to pi over 4, and so now I'm ready to write the expression. The area, which equals to theta 1 to theta 2 of 1/2 r squared d theta. This becomes the integral from negative pi over 4 to pi over 4 of 1/2. What am I going to replace r squared with?
The equation.
The equation. R squared is this. Multiply that by 4 cosine 2 theta d theta. Okay.
Yeah, you got to square it.
No.
That's r
This
squared.
is r squared.
Already.
All right. So pull the constant out. Pull the constant out, and I've got the integral of cosine 2 theta
Sine.
d theta from negative pi over 2, or pi over 4 to pi over 4. I'm going to rewrite this one more time. Are you ready?
Yeah. Are we going to do this?
4 times the integral from 0 to pi over 4 of cosine.
That is.
Why 4?
Symmetric.
Because it's symmetric. Why do the whole thing? Why don't we do half of it and double it? All right. So this is going to end up being 4 times 1/2 sine 2 theta evaluated from 0 to pi over 4, which ends up, if I continue on, ends up being 2 times sine of pi over 2 minus sine of 0. Double check my math, please. All right, so 2 times sine of pi over 2 is 1 minus 0. I get 2, and they get 2. Capiche? Yeah, I think so. I'm not Italian, so I don't know.